In this session, we are going to see previous year questions from chapter Electricity, chapter 12. So what are the 1 mark questions they have asked? So let us try to see as many questions as possible. So first question, in 2016 they asked, if the charge of an electron be 1.62 10 power minus 19 coulomb, find approximate number of electrons in 1 coulomb. This is a direct in-text question which they have asked in 2016. So we know already we have solved it. Q is equal to N into E, and in this we need to find the N value. So N is equal to Q by E. Q is nothing but 1 coulomb upon charge of electron 1.6 into 10 to the power of minus 19. So it will be like 1 by 1.6 multiplied with 10 power minus 19. If it is going to numerator, it becomes 10 power plus 19. 1 by 1.6 value is 0.625 into 10 power 19. Now if you want to move this point forward, one value will be reduced here, so it becomes 6.25 into 10 to the power of 18. So number of electrons in 1 coulomb is equal to 6.25 into 10 to the power of 18 electrons. Now second question, list any 2 factors on which resistance of a conductor depends. Basically 4 factors we can write. Now they have asked only 2 factors, and that is also for 1 mark. You see, we are seeing only 1 mark questions, so we can write any 2. First one, resistance directly proportional to length, so length is 1 factor. Second one, resistance is inversely proportional to area of cross section, that is second factor. Third one, if you want, you can write it as temperature. And fourth one, nature of the material. Nature of the material. Now in 2016 question, what is the SI unit of potential, electric potential? You see, electric potential or potential difference is nothing but voltage. SI unit of voltage is volt. So you see, if they are asking any 1 mark question, try to write answer very simple and precise. No need to write very lengthy answers. It is okay to write 1 word. So in this, volt is the SI unit of electric potential. There is no need for you to write this much big answer also. Just you can write SI unit is equal to volt, enough, or SI unit of voltage is equal to volt. Basically they are going to see only the word volt, they will tick and they will give 1 mark. Fourth question, so in the second question also you can say they have asked list any 2 factors. Just you have to list 2 factors, that's it. They are not asking like is directly proportional to length, so length is one of the factors. Resistance is inversely proportional to area of cross section, so area of cross section is another factor. No need all these. Fourth question, when is potential difference between 2 points said to be 1 volt? This is also direct in-text question from textbook 2016 they have asked. So when we can tell, we know formula na, V is equal to W by Q. S unit of voltage is 1 volt is equal to S unit of work is 1 joule, joule upon S unit of charge is coulomb. For everything if you apply 1. So when we can tell, when potential difference is 1 volt, when 1 joule of work, you see, if amount of work done in bringing 1 coulomb of charge between them is 1 joule, means 1 joule of work done to bring 1 coulomb of charges is nothing but 1 volt. Like that you can tell the answer. And again in 2016 they asked state Ohm's law. We need only statement, that's it. So if the physical conditions of conductor remain same, or if physical conditions are constant or at constant temperature, whatever sentence you want you can start. At a constant temperature, current through a conductor is directly proportional to potential difference. That's it. That's it needed between 2 ends of conductor. So current is directly proportional to voltage. Again, after by removing this proportionality constant, we'll be getting one constant. Directly proportional, we can add one constant, that is R. So we know V directly proportional to I, and V is equal to I into R, like that. In 2015 they asked another question, mention one reason why tungsten is used for making filament of electric lamp. Why only tungsten? Tungsten is used for making filament
for high melting point, sir.
Yeah, because of its high melting point as well as low resistivity. It has very least resistance and at the same time high melting point. So some amount of temperature also will be increased. Though temperature is increasing, it will not melt at certain temperature. That is why we are using tungsten. Seventh question. A. Name the instrument or device used to measure electric current in a circuit. B. How an ammeter connected in circuit to measure current flowing through it. You see how stupid this question is. They have asked what is the device which is used to measure electric current and how ammeter is. So ammeter is the answer. So the question itself we have answered in 2015 as given like this. So ammeter, just if you write ammeter, that is more than enough, you will get half mark. And B, how ammeter is connected? Simply if you write series, no need, just only two words enough. No need to frame sentences also. If you want, you can frame sentence. After framing sentence, what you can do, series is the heart of the answer. So underline that series. So straight away, what will happen? His eye will go to that series. Okay, here also ammeter is used. If you want, you can write big sentence. Ammeter is the device which is used to measure electric current. Try to underline the ammeter. Straight away, he will correct ammeter and he will put half mark. Ammeter is connected in series in an electric circuit. Underline this series. Straight away, he will correct that series. He will assign half mark. Half and half, you are going to get 1 mark. Next, 8th question. In an electric circuit, state the relationship between direction of conventional current and the direction of flow of electrons. Very most important. What is the relation? It is quite simple. Electrons, or electron means negative charge, always it is generated at negative terminal. So if they are asking about direction of electrons, straight away you can write it as electrons always will be flowing from negative terminal to positive terminal, because electrons are negative charged particles which are generated at negative terminal. And conventional current, which is opposite to flow of electrons. Electron flow from, you see, electrons flow from negative terminal to positive terminal, where current flows from positive terminal to negative terminal. So this is main important. Conventional current and electron flow are opposite to each other. That is the heart of the answer. Next, 9th. How does the resistivity of alloys compare with those of pure metals from which they may have been formed? So in 2014 they asked, basically resistivity of pure metals is less, so that only metals are good conductors. Metals are good conductors. Why? Because it has very least resistivity of alloys. Which are these alloys are made? So how does resistivity of alloys compare with those pure metals from which they have been formed? So if they ask resistivity of pure metals is lesser than resistivity of alloys, so that alloys are different. And alloys will have high resistivity. In 2014, another question they asked, write SI unit of resistivity. You see, SI unit of resistance, SI unit of resistance is ohm. SI unit of resistivity is ohm meter. 11th, state a difference between wire used in the element of an electric heater and infused wire. In fuse, what type of wire we are using? In electric heater, what type of wire we are using? The wire used in element of electric heater has high resistance. It should has high resistance, so that if you are passing current continuously, if temperature is increased also, if more amount of temperature is increased, that should not melt, because it should has high melting point. Whereas fuse wire should have, it should has a low resistance and low melting point, so that for our house we are getting something around 220 to 230 volt. If huge amount of voltage if you are getting, maybe like 240 volt if you are getting, that leads to damage of all the devices now. So that fuse wire, it that should have low melting point, so that if 240 volt is passing, straight away that has to melt and that fuse wire has to cut. So now the heart of the answer is the wire used in the element of electric heater has high resistance. You have to underline this, high resistance and high melting point. While coming to fuse wire, low resistance, low melting point. So they will correct this. High resistance, high melting point, half mark. Low resistance, low melting point, half mark. You are going to get 1 mark. 12th question. Power of a lamp is 60 watt. So P is equal to 60 watt. Find the energy in joules. So energy or W, both are same. Energy or work or heat. Okay. Consumed in 1 second. T is equal to 1s. So we know power is equal to work by time, right? So our energy by time, which is nothing but 60 by 1, that is equal to 60. So what he asked, he asked work, right? So what to do? Work is not 60 here. Power is 60. 60 is equal to W by T. So W is equal to 60 into T. So 60 into T, that is 60 into 1, which is nothing but 60 joule. You can write either work or you can write either energy, whatever. Both are correct. Now in 2011, they asked another question. Draw a schematic diagram of a circuit consisting of cell, so not battery, cell 1.5 volt, 10 ohm resistor and 15 ohm resistor and plug key all connected in series. That is a hint they have given. So what we can do, you can draw one cell with a positive and negative terminal. You have to mention its value 1.5 volt, and towards negative side always try to connect key, and which is connected to 10 ohm resistor and 15 ohm resistor, all are connected in series. So one resistor with 10 ohm capacity, another resistor with 15 ohm capacity, connect everything in series. Like that you have to mention. 14th, again in 2011, why do we use copper and aluminum wire for transmission of electric current? Simple, many conditions you can write. Copper and aluminum wires are used for electric transmission due to their low resistivity, because good conductor will have least resistance. Try to understand. Good conductor will have least resistance value. Resistor, alloy will have more resistance, high resistance. So that only because of low resistivity, we are using copper and aluminum. That's it. 15th question. Give an example. Guys, an means only one needed. No need to write 2 to 3. Give an example of metal which is best conductor of heat. Any one you can write. Gold is very good conductor of heat. Silver, copper. So basically metals are good conductors of heat. Just answer what you can write, just you can write gold and leave it. They will correct, they will give 1 mark. Done. 16th. Define electric circuit. Distinguish between open and closed circuit. In 2010 they asked. So define electric circuit. This is also direct question from your in text. Electric circuit is the arrangement in which electric current can flow when circuit is switched on, or you can write it as it is closed continuous path where current passes. Simple definition you can write for electric circuit. Okay, what is the difference between open and closed? In open circuit, there is no flow of current, that is a heart, as switch is off. In closed circuit, current flows. That's it. Because we are switching on and we will be plugging on tab key, switches, everything. 17th. What is the lowest resistance that can be obtained by combining 4 coils of resistance 4, 8, 12, 24? Just a small logic we have to remember. If you take resistors, if you want high resistance value, we have to connect always in series. If you want low resistance value, always you have to connect in parallel. Simple logic, try to remember this. Now what they are asking, lowest resistance they are asking. If you want lowest resistance, always you have to connect in parallel. We know formula 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. 1 by R1 value is 4, 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. Now LCM is 24, 4, 6, 24 plus 8, 3 is 24 plus 12, 2 is 24 plus 24, 1 is 24, 6 plus 3, 9, 10, 11, 12, it will be 12 upon 24, 12 ones, 12 twos. So 1 by R is equal to 1 by 2. If you reciprocal this will be reciprocal. At last we will get R is equal to 2 ohm. So that is the least resistance we can get if you connect all resistors in parallel. If you connect in series, you see what happens. You see this is first resistor, second resistor, third, fourth. First resistor value 4, second resistor value 8 ohm, third one 12 ohm, next 24 ohm. If you connect in series, what happens? 24 plus 12 plus 8 plus 4, 8 plus 2, 10, 14, 18, 2, 3, 4, 48. Guys, if all resistors are connected in series, you are getting 48 ohm. If all resistors are connected in parallel, you are getting 2 ohm. You see, if you want high resistance value, go with series. If you want least resistance value, go with parallel. Now, another question in 2010, they asked, nichrome is used to make element of electric heater. Why? Nichrome, it is combination of nickel and chromium. Nichrome is used to make element of electric heater because nichrome is an alloy. Nickel and chromium, combination of 2 or more metals, nothing but alloy. So what is the specialty of alloys? High melting point and high resistance. Many times this point got repeated. So resistors, high melting point, high resistance, alloys. So we completed 18 questions. Let us see remaining. Okay, 19th one. Okay, what happens? What happens to the resistance of a conductor when length of conductor is reduced to half? We know resistance directly proportional to L. If L is becoming L by 2, means if wire has this much, it has some resistance value. If length is becoming half, now resistance is directly proportional to length of the conductor. If length becoming half, resistance also becomes half L because it is directly proportional. So LHS and RHS, if both are directly proportional, if right hand side element is increasing, left hand side also will increase. If right hand side is decreasing, left hand side also will decrease. So if L is becoming L by 2, R also becomes R by 2. Simple logic, becomes half of its initial value. So is the heart of the answer is resistance also become half. 20th question. What happens to the resistance of conductor when temperature is increased? The resistance of conductor also increases because we have discussed 4 factors affecting resistance. Length is one factor, area of cross section is another factor, temperature is another factor, nature of material is another factor. So everything R directly proportional to L, R directly proportional to, okay, R inversely proportional to A, R directly proportional to temperature. So when temperature is increased, resistance of conductor also increases. 21. In 2000, they asked, draw a schematic diagram of an electric circuit consisting of battery of 2 cells of each. You see, battery of 2 cells. They'll give you battery of 4 cells, battery of 2 cells, battery of 3 cells, something like that. So battery of 2 cells of each 1.5 volt, 5 ohm resistor, 10 ohm resistor, 15 ohm resistor, and plug key, all connected in series. Everything must be in series. So first what we can do, you can draw battery. Battery of how many cells? 2 cells. That is a hint. Positive, negative, negative connected to positive and negative. Positive here, negative here, and you can mention 1.5 volt, 1.5 volt, or straight away you can mention it as 3 volt. No worries. Okay, it is better to mention 1.5 volt, 1.5 volt. And key, of course, you can connect towards positive or negative. Maximum try to connect towards negative. What is their key? And 5 ohm resistor, 10 ohm resistor, 15 ohm resistor, all connected in series. Like that you have to draw. 22. In 2006, they asked. So many years back, okay. Out of the two, a toaster of 1k watt and electric heater of 2k watt, which has greater resistance, they are asking. You see, we know formula P is equal to V into I. Okay, so in 2006, they asked, this is somewhat a tricky question, try to understand. P is equal to V into I, we know. And if you substitute V is equal to IR, P is equal to I square R, we will get. Again, if you substitute Ohm's law, from Ohm's law, V is equal to IR, I is equal to V by R. If you substitute, it becomes P is equal to V square by R. Now, if you need R, send that R that side, get this P this side, it becomes R is equal to V square by P. So from this, what we can infer is resistance, you see, this R LHS and P RHS, which is in the denominator. So R is inversely proportional to P. So from this, what information we can get is, or not only this one, from this also directly we can take P is inversely proportional to R. Means if power is increased, resistance will decrease. That is the meaning. So here power is increased in 2 kW. So 2 kW power is increased, resistance value will be less. 1 kW power is less, resistance value will be more. So we know R is directly inversely proportional to P. So more power, lesser resistance, vice versa. So toaster has lesser power 1 kW than electric heater 2 kW. Therefore, resistance of toaster more than heater. Toaster is 1 kW, so toaster is more than heater. Like that we can write the answer. Okay, again in 2005, basically this question got repeated in 2010 or 11 somewhere. Why is tungsten metal selected for making filaments of incandescent lamps? Okay, in lamps, in bulbs. Why? Because it has high resistance and high melting point. 24. A wire of resistance 5 ohm is bent in form of a closed circle. So there is wire, it seems, which is bent in form of closed circle like this. What is the resistance between 2 points at the end of any diameter of circle? Okay, now when it is bent like this, you see how tricky these questions are. Now in 2010, 11, 12, 16, 20, questions are somewhat easy. But if you observe this 2005, 2004, 2003 questions, much tricky. Now you see, when it is bent in form of circle, if you draw, what they're asking, what is the resistance between 2 points at the end of any diameter? Now diameter, if you draw this point and this point, what is the resistance value? Now it can be assumed as 2 semicircular elements are connected across diameter AB. So if we consider this one AB, we can consider one semicircle part and another semicircle part, both are connected. Let us assume total resistance of couple wire is 5 ohm. The resistance of semicircle is 5/2, means entire circle is 5. If you are taking only half part, this A, this part, if you are taking only this part, resistance is, because half of the circle resistance is by 2, 5/2. Now both are connected in parallel, because this is top upper part, this is bottom part, both are connected in parallel. Series means side by side, parallel means one upon another. Now resistance value is 5/2. Now we need a resistance in parallel. 1/R is equal to 1/R1 plus 1/R2. Why? Because we have two semicircular tracks, two semicircular coils. 1/R1. So you can substitute like this. 1/R1 value is 5/2 plus 1/R2 value is also, if this upper part is 5/2, bottom part is also 5/2. Now 1/5/2 becomes 2/5. You like this, 2/5 plus 2/5, that is equal to LCM 5, and 2 plus 2, 4, 4/5. So new resistance value or resistance between these 2 points will be 5/4 ohm. Like that you have to write answer. Next, 25th question. Why is much less heat generated in long electric cables than filament in electric bulb? You see, there is bulb, it seems, there is filament as well as conducting wire. So in wire less heat is generated, but in filament high heat is generated. Why? Because wire is made up of conductor, just normal conductor. This filament is made up of tungsten. So this conductor, which is nothing but copper, which has least melting point and least resistance. Tungsten will have high resistance, high melting point. Done with that. Tungsten wire whose resistance is high and melting point is also high, so that only in filaments only high heat is generated than conductor. It is quite simple answer. Okay, next. In 2005, which has higher resistance, 50 watt or 25 watt lamp bulb, and how many times? So already we have discussed one thing, na? Power is inversely proportional to resistance. When power increases, resistance must decrease. So 50 watt, 25 watt, 50 watt high power, so it has least resistance. 25 watt least power, it has high resistance. Done. So power 1 is equal to 50 watt, power 2 is equal to 25 watt. We know P is equal to V square by R, or R is equal to V square by P. And R1, resistance 1, if you take V1 by 50, R2 V2 by, or V square, sorry, V square by 25. If you take ratio R1 by R2, R1 value what we got? V square by 50 upon R2 value V square by 25. V square gets cancelled. We will get 1 by 50 upon 1 by 25. This can be written as 1 by 50 multiplied with 1 by 25. It is going numerator reciprocals, 25 by 1. It becomes 25 by 50. 25 ones, 25 twos. So answer is 1 by 2R. So how much it will differ? Half of the resistance will be reduced. So 50 watt bulb has half resistance than 25 watt bulb. Next, in 2004, one question they asked, define resistivity. So resistivity of material is resistance of conductor of this material whose volume is unity. Or one other thing what you can tell, we have R is equal to rho L by A. Na? If area is 1, length is 1, then resistance is equal to resistor, means resistivity of a material is the resistance of conductor. So what resistance of conductor has, that is only resistivity. If the material whose length and area of cross section both are unity, unit means 1, unity means 1. So how much length, that much area of cross section if you have, then resistance is equal to resistivity, they will tell. Next, 28th question. This is numerical one. So we'll see remaining questions in next lecture. That's it in this lecture.